What can computational power networks bring to us? As an important support for the rapid development of emerging digital industries such as big data, cloud computing, blockchain, artificial intelligence, and network security, computing power is closely related to the development of digital core industries such as the internet industry, electronic information manufacturing, and digital technology services. In recent years, computing power technology has been continuously extending from high-tech and cutting-edge industries to various fields closely related to our lives, and various types of integrated applications are emerging in competition. As an important foundation for unleashing the advantages of data and promoting the innovative development of the digital economy, the construction of computing power networks is becoming a hot area for promoting the development of the digital economy and playing an investment-driving role in various regions. Nowadays, people commonly use digital convenience services such as online medical care, online shopping, palm-based enrollment, intelligent travel, and intelligent meter reading are all supported by computing power. What is computing power? What is a computing power network? Computational power is the infrastructure and core driving force of the digital era. The ability to process data and information on demand through computing devices is called computational power. Zhen Jianguang, partner of data intelligence consulting services in Ernst & Young Greater China, said that the narrow meaning of computational power is the amount of information data that a device can process per second, in terms of the number of floating point operations per second, flops, that is, the number of floating point operations per second, used to measure the computational power and execution efficiency of a computer. Especially in fields such as scientific computing, graphics and image processing, and AI applications that use a large number of floating point operations, the magnitude of computing power directly affects the accuracy and efficiency of computing, and has a direct impact on scientific research, production, and commercial applications. Generally speaking, industrial control and Internet of Things acquisition require small computing power, real-time acquisition decision-making and machine vision, reasoning. Computing power requirements are medium computing power, video rendering and cloud AR/VR/XR and machine vision. Training. Computing power require large computing power. Supercomputing and big data processing require super large computing power. For example, the Tianhe-2 supercomputer, assembled by the University of National Defense Science and Technology of China in 2021, had a computing power of 30.65 flops, making it the strongest supercomputer in the world at that time, 74% higher than the computing power of the second-ranked American Titan supercomputer. By 2024, Shanghai's total computing power would exceed 15 flops, fully meeting the computing power requirements of ultra-large and above, and would far exceed the computing power of existing supercomputers. Zhen Jianguang said that with the acceleration of the digitization process, computing power is also iterating spontaneously. However, to fully meet the various computing needs of the entire industry, it is necessary to perceptively connect and coordinate the scheduling of distributed and heterogeneous computing power through the network. Therefore, computing power networks emerged as the times require. In the era of digital economy, data has become a new type of production factor, showing an explosive growth trend. According to the National Data Resources Survey Report, 2021, throughout 2021, China's data output reached 6.6 ZB, a year-on-year increase of 29.4%, accounting for 9.9% of the global data output, 67 ZB. In the past 3 years, data output has maintained a growth rate of about 30% annually. With the continuous increase in data volume, the market's demand for computing power improvement is becoming increasingly urgent. However, due to the constraints of physical factors, Moore's law, which dominates the chip industry, is gradually approaching the limit. The space for the growth of computing power in data centers and intelligent terminals will face significant challenges. Centralized cloud computing cannot meet the landscape requirements of low latency, large bandwidth, and low transmission costs. In the era of continuous data growth, relying solely on the two-level computing architecture of terminal plus data center to process data has become inadequate. It is inevitable that computing power will spread from the cloud and end to the edge of the network, and computing network is a new network architecture proposed to address this shift. Computing network uses cloud network integration technology, SDN/NFV, and other new network technologies to deeply integrate edge computing nodes, cloud computing nodes, and various network resources including WAN, reduce the management and control complexity of edge computing nodes, and form a new generation of information infrastructure through centralized control or distributed scheduling methods in collaboration with computing and storage resources of cloud computing nodes and network. Resources of WAN provide customers with overall computing services that include computing, storage, and connectivity, and provide flexible, schedulable on-demand services based on business characteristics. Computing power network investment can drive economic output and is an important driver of the development of the digital economy. Various regions have come up with practical strategies and real moves to lead the comprehensive promotion of relevant construction. As an important city for the construction of computing power facilities in the West, Qinghai Provincial Communications Administration and Qinghai Provincial Department of Industry and Information Technology jointly released the action plan for the construction of Green Zero Carbon Computing Power Network, 2023 to 2025, with a view to giving full play to the advantages of Green Zero Carbon, vigorously promoting the construction of Northwest Digital Valley, promoting Qinghai to become an important carrier of East Digital Valley, and actively integrating into the national layout of East Digital Valley. The action plan sets the overall goal of Qinghai Provincial Computing Power Network. By 2025, the green energy conservation level of data centers will lead the country, with a large data center rack size of over 100,000, and a total computing power of over 2.06 EFLOPS. The PUE, energy efficiency, of the newly built data center will be strictly controlled below 1.2. On January 4, Qinghai Xining National Internet Backbone Direct Link application was approved by the Ministry of Industry and Information Technology. This news has injected strong impetus into the construction of Qinghai's Northwest Digital Valley. The reporter learned from the Information Development Department of Qinghai Provincial Communications Administration that the Bureau has organized 3 basic operators, namely Telecom, Mobile, and Unicom, to build a national backbone direct connection point for Xining's internet, and plans to complete it by the end of this year. The monitoring platform will be established by relevant departments under the leadership of the Communications Administration. The staff of this department stated that in the construction of the computing power network, the Internet Backbone Direct Connection Point is like an information transmission highway. Upon completion, it will reduce the cross-regional traffic circulation in Qinghai Province, effectively improve the Internet traffic dredging ability and Internet user perception, and provide a solid network foundation guarantee for Qinghai's integration into the East Digital West Computing. The per capita available intelligent computing power exceeds 220 flops. The average utilization rate of data centers strives to increase to over 75%, and the end-to-end one-way network latency of data centers within Shanghai's hub nodes is less than 15 milliseconds. In order to better promote the development of the computing industry and give play to the advantages of computing network layout, Shanghai has released a new data center, Computing Pujiang, action plan, which explicitly proposes to reach 2024. The Shanghai hub of the National Integrated Computing Power Network has been initially built, and a high-energy computing power hub center with Asia-Pacific and even global influence has been built. As a city with an early start and a high level of infrastructure construction, Shanghai's computing power network construction has achieved certain results. In terms of technical infrastructure and computing capacity, the Shanghai Supercomputing Center was put into construction as early as 2000. Currently, Shanghai mainly conducts the construction of computing power networks through government-enterprise cooperation. For example, in 2022, the artificial intelligence computing infrastructure Shangtang Technology, which has the strongest peak computing power in China and a total investment of about 5.6 billion yuan, was also put into use in the new area near the port of the Shanghai Free Trade Zone. The AIDC, one of the largest AI supercomputing centers in Asia, has a total computing power of 3,740 flops, which will bear the heavy responsibility of large-scale artificial intelligence research and industrialization in the Yangtze River Delta region. At the same time, Tencent Yangtze River Delta Artificial Intelligence Advanced Computing Center and Ecological Industrial Park, located in the western part of Shanghai Songjiang Economic Development Zone, are also under construction. Upon completion, the number of servers will reach 800,000, and the computing power will be 10 times that of the currently ranked supercomputing center in the world. The data center is a server room that houses core computing services and infrastructure. It is used to store and calculate data, provide data support, and provide computing services. It is the main carrier of computing power. According to statistics, there are currently 291 data centers of various types built in Shandong, with a low latency edge computing power ratio exceeding the national average. According to Guo Yang, Deputy Chief Engineer of the Yunde Institute of the Chinese Academy of Information and Communications, in 2022, the indirect economic benefits brought by computing power in Shandong province have exceeded 8.2 billion yuan, and the total annual calls of convenient applications and service platforms carried by various data centers have exceeded 45.7 billion person times. How can data centers play a stronger role? Dual gigabit network support represented by 5G and gigabit optical networks is essential. It is understood that more than 160,000 5G base stations have been built and opened in Shandong, with over 153 million Internet of Things end users. This has built a smooth and fast information artery and nerve endings that directly reach users for various data centers in the province. According to statistics, 12 cities such as Jinan, Qingdao, Yantai, and Zibo have built gigabit cities, and the national backbone direct connection points of Jinan and Qingdao have also been officially established and opened. The cross-network interworking latency of data centers across the province has generally decreased by more than 50 milliseconds. So, what scenarios will computing power networks enable? The Internet of Vehicles is the use of sensor technology to sense vehicle status information, and the use of wireless communication networks and modern intelligent information processing technology to achieve intelligent management of traffic, as well as intelligent decision-making and intelligent control of traffic information services, to achieve a comprehensive network connection between vehicles and cloud platforms, vehicles and vehicles, vehicles and roads, vehicles and people, and vehicles. The Internet of Vehicles requires extremely high network latency and stability, requiring fast switching of computing nodes as vehicles move at high speeds. Scheduling delay in sensitive services, such as vehicle entertainment, from local nodes to other nodes for computing through computing power networks to reduce the load on local nodes, allowing delay-sensitive V2X assisted driving services to be prioritized at the nearest local idle node, ensuring their user experience and availability. With the development of cloud computing, artificial intelligence, big data, and other technologies, security systems are upgrading from traditional passive defense to intelligent defense based on active judgment. Through intelligent video monitoring, more information can be obtained, and based on this information, analysis and judgment can be made. Using big data analysis, on-site restoration can even be carried out after case investigation and pre-judgment conversion. To achieve this goal, it is necessary to integrate more ICT capabilities, combined with cloud, edge, and end collaboration capabilities, to improve their own intelligent processing capabilities. Cloud games are game modes based on cloud computing. In the cloud game operation mode, all games are run on the server side, and the rendered game images are compressed and transmitted to users through the network. However, cloud games require very high bandwidth and latency, and computing power networks provide a basic guarantee for improving the quality of cloud games, making the gaming experience smoother. The construction of computing power networks will provide high quality, low latency, and low-cost computing power for industrial innovation, including the underlying infrastructure, IT, and network equipment in the upstream of the industrial chain, communications, midstream telecommunications operators, mobile, Unicom, telecommunications, tower, etc., third-party data center operators, and downstream industries such as the internet, finance, and automotive will all usher in new development. Opportunities. Lian Kai, Deputy Director of Shandong Provincial Big Data Bureau, said that in the next step, Shandong plans to use about 3 years to promote the total number of standard racks in use in data centers in the province to exceed 450,000. Strive to promote the improvement of computing power and accelerate the layout of new data centers and low-latency edge data centers that can provide high-level cloud services. Shandong will also deeply explore the integrated application of computing power in innovative application scenarios such as digital institutions, industrial transformation, industrial internet, Internet of Vehicles, and financial technology, improve the application level of computing power in traditional industries such as medical care, transportation, and education, and promote the application of computing power in more production and living environments. The enhancement of computing power also puts forward higher requirements for green environmental protection. On September 22, 2022, the General Office of the People's Government of Qinghai Province issued a notice on the issuance of the Work Plan for accelerating the integration of Qinghai Province into the national layout of the East Counting and West Counting program. The plan proposes to promote energy consumption, relying on water resources such as the upper reaches of the Yellow River, as well as the two clean energy bases of 10 million kilowatts in Hainan and Haishi. Priority is given to ensuring the supply of green power resources for big data centers and promoting the rational allocation of power resources. By 2025, the green power consumption of Qinghai Big Data Center will reach over 1.7 billion kilowatt-hours per year, and the utilization rate of clean energy will reach 100%. The plan proposes to build large and above data centers in Qinghai to concentrate on the Xining Haidong Computing Power Cluster and Hainan Reserve Cluster sides, and gradually guide the orderly development of renewable energy-rich areas such as solar energy, wind energy, and hydropower. It has also set the goal of using green and renewable energy, actively adopting advanced energy-saving technologies and equipment, promoting resource recycling, and reducing energy consumption in the data center. In combination with building a national clean energy industry highland, Qinghai promotes data centers to make full use of renewable energy such as solar energy, wind energy, hydropower, and other renewable energies, coordinate and balance low-cost guaranteed electricity in the province, continuously improve the peak and valley time of use electricity pricing mechanism, reasonably mediate relevant electricity price conflicts, effectively control the power consumption cost of data centers, and attract a number of high-quality enterprise projects to settle in.